Yes, here I am back after a long time, and today I am going to explain a very important topic from class 10th advanced math from chapter number 3. Chapter number 3, arithmetic integer, contains very important topics. The first part of this chapter contains mathematical induction, but in this video I am not going to explain about this part. I am taking the second part as divisibility part, and divisibility part is also important for you. Divisibility part in number theory plays a great role. You have to understand the definition, you have to understand the properties, theorems to solve the problem, to solve the questions easily. Okay, without wasting any more time, let us try to understand the definition and properties. First, try to understand the definition, divisibility. For example, we are taking two integers, that a comma bb, two integers. Remember that here a not equals to 0. Okay, then we can say that a divides b. There is a condition if there exists another integer c such that b equals to ac. This is the most important part here, that if a divides b, then we can write b equals to ac. Here c is another integer. Okay, here a divides b. How symbolically you can write that a divides b? This is like this. Here it is a divides b. Whatever you will get by giving this symbol in number theory, it means that this one divides this one. Okay, and if a divides b, then you can write b equals to ac. Here c is another integer. Okay, here it is a divides b. Also here if a divides b, then a is what? A factor of b. A is a factor of b. Also you can say that a is a divisor of b. Also here b is what? B is the multiple of a. You can say that a divides b, or a is a divisor of b, a is a factor of b, or b is the multiple of a. How? I am taking one example. Suppose 6, the factor of 6, 1, 2, 3. Okay, and 6 is itself also. Then for example I am taking 2, then 2 is a factor of 6. You can write, right? Then 2 divides 6 also. Okay, here always remember that a divides b, remainder is 0. Here b is completely divisible by a. Understood? Let me explain about two more important definition, that proper divisor and improper divisor. Okay, for example a divides b. Okay, a is a proper divisor of b if a is not equals to plus minus 1 comma plus minus b. Okay, and improper divisor, a divides b, a is improper divisor divisor if divisor of B if A equals to plus minus 1 comma plus minus B. For example, the factors of 6 are what? Plus minus 1, plus minus 2, plus minus 3, plus minus 6. Then here plus minus 1 comma plus minus 6 are what? Are improper divisor. And plus minus 2, plus minus 3 are what? Proper divisor. Plus minus 1 and plus minus 6 are improper divisor of which one? Plus minus 1 and plus minus 6 are improper divisor of 6, and plus minus 2 and plus minus 3 are proper divisor of 6. Okay, here that A divides B, here plus minus 1 also divides 6. Okay, plus minus 2 also divides 6, plus minus 3 also divides 6, plus minus 6 also divides what? 6. Then here this one plus minus 1 and this one plus minus 6 are what? Improper divisor of 6, and these plus minus 2 and plus minus 3 are what? Proper divisor of 6. Understood? I hope you understood the meaning of that proper divisor and improper divisor. Okay, now most importantly, let us move to the theorem part. Yes, you have to understand the theorems better to solve the questions of this chapter easily. Here I have written two important theorems, and this one here, A, B, C, D are what? Integers. If A divides B and C divides D, then AC divides BD. It is given that A divides B and C divides D, then you have to show that AC divides BD. Okay, proof. It is given what? A divides B. Then by definition of divisibility, what you can write? That B equals to AR. Here R is another integer. In divisibility, definition of divisibility, what we have learned, that if A divides B, then you can write B equals to AC. At that time B equals to AC, where C is another integer. I am writing here R as integer. Okay, here R is another integer, and again it is given that C divides D. From here you can write D equals to CS. S is integer, S is arbitrary integer, R is arbitrary integer. Okay, now we have to show that AC divides BD. Okay, here BD, we know B equals to AR, D equals to CS. Now if you just multiply D with B, then you will get B equals to, B was what? AR, and D was what? CS. Okay, implies that BD equals to, you can write AC to RS. Here RS is an integer. Okay, from this line you can write that AC divides BD. How? By definition of divisibility. Okay, I am explaining once more that A divides B and C divides D. It is given A divides B. If A divides B, then you can write B equals to AR by definition of divisibility. Here C divides D, you can write D equals to CS by definition of divisibility. Here R and S are what? Integer. Exactly, you have to show that AC divides BD. Now if you find out BD, then easily it will be what? B was what? AR, and D was what? CS. Then AR into CS, then AC, here RS, if you consider another integer, then easily by definition of divisibility, from this step you can write AC divides BD. Understood? Here another most important theorems, and these theorems exactly, it is what? Exactly that A divides B and B divides C, then A divides C. It is what? Transitivity. Let us prove this theorem. It is given that A divides B then from this one you can write b equals to, for example, another integer there exists, what, r. R is what, integer, and again b divides c, you can write c equals to bs, what, here s is another integer. Okay, since you have to show that a divides c, okay, and c, what you can write, bs, therefore c equals to bs. Instead of writing b, let us write the value of b here, that you know b equals to what, ars, and this one you can write rs, and here rs what, integer. Then from this step easily you can write a divides c by definition of divisibility. What exactly this a divides c, you need to show that. Okay, and here this one what, by definition of divisibility. The theorem was what, if a divides b and b divides c, then a divides c. Okay, in proof it is given that a divides b and b divides c. If a divides b, then there exists another integer r such that b equals to ar. By definition of divisibility you can write, if a divides b, then b equals to ar. If b divides c, then you can write c equals to bs, where s is another integer. Okay, since you have to show that a divides c, so I am writing here c equals to bs. What you know that, and instead of b I am putting here that b equals to ar, and exactly we can write from this step that c equals to ars, and here rs is integer, and by definition of divisibility you can write what, a divides c. I hope you understood this both theorem. Another theorem is what, if a divides b and b divides a, if, that means if and only if a equals to plus minus b. Okay, I have written this whole in the board not to waste more time. Let us understand that proof, it is given that a divides b and b divides a. If a divides b, then we can write b equals to ar, here r is an integer, and if b divides a, then we can write a equals to bs, here s is another integer. Okay, since a equals to bs, okay, instead of writing b, let us put here ar, since b equals to ar. Okay, a equals to ars. Okay, this a get cancelled, it will be what, 1 equals to rs. Okay, 1 equals to rs, it will be possible if r equals to 1 and s equals to 1. Okay, that 1 into 1 exactly 1. Okay, or else if r minus 1, then s will be minus 1 and it will be 1. Okay, that means if r and s both is 1, then it will be 1, or if r and s both is minus 1, then it will be 1. That's why I have written that it is possible if r equals to s equals to 1, or r equals to s equals to minus 1. Okay, now a equals to bs, since s equals to what, minus 1 and s equals to 1, let us put the value. If s equals to minus 1, then a will be minus b, and if s equals to 1, then a will be what, b. Therefore we can write a equals to plus minus b. Since it is here that if and only if, so we need to show it conversely. If you take that b equals to plus minus a, okay, then when b equals to a, at that time you can write b equals to a into 1. From here you can easily write a divides b. Okay, similarly you can write a equals to b into 1. From here you can write b divides a. Similarly, when b equals to minus a, at that time you can write b equals to minus 1 into a. From here you can write a divides b. Similarly, a equals to, you can write b into minus 1. From here you can write b divides a. From here what you can write, that if b equals to plus minus a, then a divides b and b divides a also, and if a divides b and b divides a, then a divides a equals to plus minus b. Understood this theorem? Let us move to the next theorem. Another important theorem is what? If A divides B and A divides C, then A divides Bx plus Cy. Here x and y are any integers. Okay, this theorem or this property is also known as what? Linearity property. Remember that this is also known as linearity property. Okay, it is given that A divides B and A divides C. A divides B, then you can write AR, where R is integer. Okay, by definition of divisibility. Again, A divides C, you can write what? C equals to AS, where S is integer. Let us take this one as equation 1 and this one as equation 2. Since with B x is multiplied, with C y is multiplied. Here in equation 1 B equals to AR. Let us multiply equation 1 into x. Let us multiply x with equation 1. It will be what? Bx equals to ARX. And let us multiply y with equation 2. Equation 2 multiplied with y, you can write what? Cy equals to what? ASy. Okay, since here bx plus cy, here we got bx and cy, let us add this both part. Bx plus cy, bx was what? ARX plus cy was what? ASY. Easily the next step, from ARX and ASY you can take A as common, RX plus SY. Okay, and from this step easily you can write A divides BX plus CY. Here RX and SY what? Integer, and A divides BX plus CY. From where you got? From this step you got, and exactly by definition of divisibility. Okay, I hope you understood this theorem. Another theorem, if A divides B and B not equals to 0, then mod A is less than or equals to mod B. Okay, since it is given that A divides B, we can write what? B equals to AR for some integer R. Okay, now since here mod A is less than or equals to mod B, let us apply mod here. It will be what? Then the next step will be what? Mod A, mod R. One thing, mod R, since mod R, obviously it will not be negative, it will be greater than 1 or equals to 1. That's why you can write what? Mod B equals to mod A, mod R greater than or what? Mod A to 1. From here easily you can write what? Mod A. Exactly what we need to show, that mod A is less than or equals to mod B. I hope you understood this theorem. Okay, and in the next video I will explain the mathematical induction part to prove other theorems and to solve the questions. Okay, thank you.